On Christmas morning, while most of us were opening presents, something extraordinary happened on the sun. A sunspot appeared out of nowhere and within 24 hours evolved into the most dangerous magnetic configuration we can observe, beta gamma delta. NASA's Solar Dynamics Observatory captured it all. And right now, this region designated AR4321 is pointing directly at Earth. The last time we saw a sunspot with this exact structure, it unleashed an X-class flare that knocked out radio communications across an entire continent. Welcome back. Let me put this in perspective. We haven't seen an X-class solar flare since December 8th. That's 18 days of relative calm. Solar Cycle 25 has been remarkably active this year, 0 spotless days in 2025, something we haven't experienced in over a decade. But AR4321? This is different. The beta-gamma delta classification isn't just a technical term. It describes a sunspot where opposing magnetic polarities are compressed together within a single umbra, the dark heart of the spot. Think of it like twisting a rubber band tighter and tighter. Eventually, something has to snap, and when it does on the sun, the energy release is equivalent to billions of nuclear weapons. The question isn't if AR4321 will erupt. The question is when and how powerful will it be? Here's what makes this particularly fascinating. AR4321 emerged on December 24th in the sun's southwest quadrant. Within one rotation, that's roughly 24 hours, it expanded in both size and magnetic complexity. The helioseismic and magnetic imager aboard NASA's SDO shows us something crucial. The magnetic structure is asymmetric. Why does that matter? Asymmetric configurations are historically associated with the most energetic flare potential. The magnetic field lines are tangled, sheared, and under enormous stress. Dr. C. Alex Young from NASA Goddard described it as one of the most magnetically complex regions we've tracked this month. Now, AR4321 has already produced several C-class flares, common, relatively weak eruptions, but yesterday at 0609 UTC, it released a C2.3 flare. That's a warning shot, a test of the system. What concerns solar physicists isn't what AR4321 has done, it's what it's building toward. And here's where it gets interesting. We're not alone in watching this. 7 numbered active regions are currently visible on the sun's Earth-facing side. That's significant. AR4321 has been producing flares all week. AR4319 is showing growth. But AR4321 dominates the conversation because of one simple fact: it appeared fast, evolved faster, and achieved maximum complexity in record time. Some of you remember the Carrington event of 1859, an X-45 class flare, the most powerful solar storm in recorded history. Recent simulations show that if a similar blast hit Earth today, it would knock out every satellite in orbit and cause over $1 trillion in damage. Now, I'm not saying AR4321 will produce an X-45, that's extraordinarily rare, but even a moderate X-class flare, say X1 or X2, can cause significant radio blackouts, GPS disruptions, and auroral displays as far south as the northern United States. So what should we expect in the next 48 hours? NOAA's Space Weather Prediction Center is monitoring AR4321 continuously. The flare probability for the next 24 hours, moderate M-class flares are likely. X-class flares are possible. If AR4321 does produce an X-flare and releases an Earth-directed coronal mass ejection, we could see geomagnetic storm conditions by December 28th or 29th. That means potential auroras, the northern lights, visible across Canada, Scandinavia, Alaska, and possibly the northern tier of US states. It also means increased radiation exposure for astronauts aboard the ISS, potential satellite anomalies, and possible disruptions to high-frequency radio communications. But here's the remarkable part. We're watching this unfold in real time. Every 3-hour period, NASA updates the magnetic field configuration. Every flare is cataloged. Every coronal mass ejection is tracked. This is planetary defense in action, not against an asteroid, but against the sun itself. What do you think? Will AR4321 deliver the first major X-flare of 2026, or will it quietly decay over the next few days? And more importantly, are we prepared if it does erupt? Write your prediction in the comments. X-flare or false alarm. Until next time, keep watching the sun.